A single Nvidia GPU costs $30,000. Inside many data centers, these chips sit dormant for cycles at a time. Processors solve equations faster than data can travel through the server's network. The industry calls this the memory wall. When a GPU waits for its next batch of information, it creates a vacancy in the calculation cycle. Across a cluster of 10,000 processors, these delays result in billions of dollars in wasted capital expenditure. This delay is a product of scale. Modern AI servers are deep hierarchies of hardware, linking rows of stacked GPUs to central processors through a series of physical junctions. AI performance is capped by the data loss that occurs across a few inches of copper. Data travels between these components along copper traces etched into the server's motherboard. Feeding a GPU cluster requires the PCIe Gen 5 and Gen 6 standards. These protocols move data at 32 to 64 gigatransfers per second. At these frequencies, signals experience insertion loss. Engineers use PAM4 signaling, a method that uses 4 voltage levels to pack more data into each pulse. But high-frequency PAM4 signals degrade into electrical noise after traveling just 5 inches on copper. When the receiving chip cannot distinguish the data from the noise, the system triggers a bit error. If these errors persist, the AI model crashes. The laws of electromagnetic propagation have reached a point where standard copper wiring fails, requiring a digital bridge to maintain signal integrity. Early solutions used analog redrivers, which amplified noise along with the data, leaving the output distorted. Astera's smart DSP retimer instead ingests the distorted signal, extracts the timing clock, and retransmits a clean copy, resetting the degradation budget for the entire server rack. Diversified giants like Broadcom manage portfolios spanning Wi-Fi routers and consumer devices. Astera Labs focuses exclusively on high-speed connectivity for the cloud. As PCIe data transfer speeds increase, the specialized retimer becomes a strict, mandatory requirement for Gen 6 data centers. Signals degrade at every junction in an AI server. Retimers must be placed between CPUs, GPUs, network cards, and storage. While a standard server uses 2, an 8 GPU node requires 16 to 18 retimers to maintain the system fabric. This content per server increases with the Compute Express Link, or CXL, standard. Astera's Leo memory controllers use the PCIe physical layer to share external memory pools, allowing hyperscalers to expand capacity beyond the motherboard's physical limits. Astera built a checkpoint into the hardware. Every single byte of data moving between the processors and the memory now crosses their silicon. Organizations like Google and Amazon design their own processors to save costs, yet they continue to source these specific retimers from merchant vendors. Designing for matrix math is a distinct discipline from the analog engineering required for high-frequency signaling. Retimers must also act as neutral bridges, connecting thousands of different third-party chips without logic failures. Astera maintains neutrality through the Cloud-Scale Interop Lab. By leading the PCI SIG standards body, they design silicon against pre-ratified drafts. They execute thousands of interoperability tests with partners before a standard is published. This transfers compliance risk from the hyperscaler directly to the vendor. For tech giants, buying proven silicon is a safeguard against the risk of a link failure crashing a billion-dollar AI cluster. The lock-in is a product of the design-in cycle. Certifying a retimer on a new motherboard takes 18 to 24 months of protocol-level validation. Astera adds a software layer to the physical hardware. Their Cosmos suite embeds telemetry, such as real-time signal health monitoring, directly into the hyperscaler's management console. Switching to a different retimer mid-generation requires a printed circuit board redesign. This creates a cost barrier that makes mid-cycle hardware changes impractical. Solving a physical bottleneck with high switching costs allows Astera Labs to maintain gross margins of 75%.